Welcome to the sixth problem-based tutorial. Problem statement. Demonstrate, through simulation of a half-wave diode rectifier with an RL load, how a freewheeling diode acts as a protective device. Getting started. Let's begin. Launch Simulink by clicking the Simulink icon in the toolbar. Now open example 4 we created in our fourth tutorial. Close this window. Save the model. Let's save a copy of the model. Click the drop-down menu icon next to the Save icon and select Save As. Next, give your model an appropriate name and click Save. Modify the model. We only need the half-wave rectifier circuit, so remove all the extra components from the model. Now, double-click the RL branch and set the value of R to 100 ohms and the value of L to 0.1 Henry. Next, launch the Simulink library and add a diode block. Rotate the diode block by selecting it and pressing Ctrl+R from the keyboard. Connect the diode in parallel with the load. Double-click the diode block, disable the measurement port, and click OK. Simulate the model without freewheeling diode. Let's first disable the freewheeling diode to observe the voltage waveform without it. Right-click the diode block and select Comment Out. Now, the diode has disabled. We are left with a half-wave rectifier connected to an RL load without a freewheeling diode. Click Run to start the simulation. Let's examine the load voltage waveform. As you can see, we have negative voltage spikes. These spikes can be harmful to sensitive loads. The peak negative voltage reaches approximately 93 volts. These spikes are caused by the energy stored in the inductor, which has no path to discharge once the diode is reverse biased. Simulate the model with freewheeling diode. Now, let's enable the freewheeling diode. Right-click the diode and select Uncomment. Click Run again and observe the load voltage waveform. This time, the negative voltage spikes have disappeared. The freewheeling diode provides a path for the inductor to release its stored energy safely, preventing harmful transients in the circuit. Check the effect on average load voltage. Now, let's analyze the impact of the freewheeling diode on the average load voltage. Let's add the necessary blocks. Go to the Simulink library and add a mean block. You will also need a display block. Connect the input of the mean block to the output of the voltage measurement block, and connect the output of the mean block to the display block. Double-click the mean block, set the frequency to 50 Hz, and click OK. Simulate without freewheeling diode. First, disable the freewheeling diode and click Run. The average load voltage is 96.42 volts. Simulate with freewheeling diode. Now, enable the freewheeling diode. Click Run. The average load voltage is now 98.89 volts, which shows a slight increase in comparison with the circuit without a freewheeling diode. Thus, the freewheeling diode improves both the waveform quality and the voltage magnitude, making the circuit safer and more efficient for sensitive electronic loads. Summary: in today's lecture, we simulated a half-wave diode rectifier, both with and without a freewheeling diode, to examine its impact on the load voltage waveform and magnitude. Your task: simulate the half-wave rectifier circuit with different low values and observe 1. The magnitude of voltage spikes without the freewheeling diode. 2. The change in average voltage with and without the diode. 3. The waveform shape in each case. Thank you for being with us. See you in the next tutorial.